Why did NASA send spiders into the space? How can this creature grow two heads after a space trip? And did you know that these water bears, or the hardest motherfucker on planet Earth, are the first moon residents? Scientists have conducted many unusual experiments over the years. While some have significantly advanced technology and deepened our understanding of the world, they might seem strange or unsettling to the average person. Today, I'll introduce you to some of the weirdest and most disturbing experiments ever conducted. In 1973, aboard NASA's Skylab space station, an unusual pair of astronauts embarked on an extraordinary journey. Two common garden spiders named Arabella and Anita. Their mission was to weave webs in microgravity, something no spider had ever done before. Arabella and Anita were carefully packed into small containers and launched into orbit. Back on Earth, spiders rely on gravity to orient themselves while weaving webs, using their legs and silk to create intricate structures. But what would happen without gravity? Scientists were eager to find out. As Skylab floated through orbit, the spiders faced their first challenge. In the absence of gravity, they couldn't figure out how to start their webs. Their movements seemed erratic, and their initial attempts resulted in tangled messes. It was as if they were learning to spin all over again. After a few days, something remarkable happened. Arabella and Anita began to adapt to their new environment. Instead of relying on gravity, they used spatial awareness and tactile feedback to anchor their silk. Their webs, though not as symmetrical as those spun on Earth, became functional and surprisingly organized. Scientists observed that the spiders produced thinner silk in microgravity and took longer to construct their webs. The experiment revealed that even simple creatures could adapt to space, providing clues about how other organisms might survive and evolve in extraterrestrial environments. Arabella and Anita's journey didn't end in vain. Their efforts inspired future experiments with animals in space and contributed to our understanding of how life adapts to environments beyond Earth. They became tiny pioneers, proving that even the smallest creatures could make giant leaps for science. Though the spiders didn't return to Earth alive, their story remains a fascinating chapter in space exploration. In 2019, a tiny and resilient species known as tardigrades, nicknamed water bears, embarked on an unintended adventure to the moon. These microscopic creatures, known for their extraordinary ability to survive extreme conditions, would unwittingly become part of one of the strangest chapters in space exploration. A private Israeli spacecraft, Bereshit, was on a historic mission to land on the moon. The payload included scientific instruments, a time capsule of cultural artifacts, and a special biological cargo. Thousands of dehydrated tardigrades sealed in resin. The goal was to study how these organisms might survive on the moon and to push the boundaries of astrobiology. Who are the tardigrades? Tardigrades are nearly indestructible creatures capable of surviving extreme heat, freezing cold, intense radiation, and even the vacuum of space. When dehydrated, they enter a state called cryptobiosis, in which they can remain dormant for years. This resilience made them perfect candidates for this unconventional experiment. As Bereshit approached the moon's surface, anticipation turned to heartbreak. Due to a technical malfunction, the spacecraft crash-landed on the lunar surface, scattering its payload across the barren landscape. The mission's primary objectives were lost, but questions arose about the fate of the tardigrades. Did they survive? While the tardigrades were likely ejected from their protective resin on impact, their cryptobiotic state might have allowed them to survive. Without water, they would remain dormant indefinitely, waiting for the right conditions to reanimate. However, with the moon's lack of atmosphere and extreme temperatures, their chances of thriving were slim. This accidental experiment sparked debates in the scientific community. Some praised the ingenuity of testing tardigrade survival on the moon, while others criticized the ethical implications of potentially contaminating another celestial body. The event highlighted the challenges of planetary protection and raised questions about humanity's responsibility in exploring space. Though we may never know the fate of the tardigrades on the moon, their story symbolizes the blend of curiosity and unpredictability in space exploration. These tiny, unassuming creatures became accidental pioneers, reminding us that even the smallest forms of life can push the boundaries of what's possible in the cosmos. In 1991, NASA launched a groundbreaking experiment aboard the Space Shuttle Columbia to explore how life begins and adapts in the weightlessness of space. But instead of humans or mice, the starts of this mission with jellyfish, tiny, translucent marine creatures chosen for their unique ability to sense gravity. Jellyfish have specialized structures called statoliths, tiny crystals that help them detect gravity and orient themselves in water. Scientists wondered what would happen to jellyfish if they developed in a microgravity environment. To find out, hundreds of moon jellyfish polyps were sent into space in specialized bags filled with seawater. Once the shuttle reached orbit, the experiment began. The polyps began transforming into Medusa, the adult form of jellyfish. In space, they floated and pulsated in ways that seemed natural, oblivious to the absence of gravity. Observing their development, scientists noticed that the jellyfish grew and multiplied just as they would on Earth. After several days, Columbia returned, carrying with it a new generation of spaceborn jellyfish. The real test began on Earth. How would these jellyfish handle gravity after spending their entire lives in microgravity? When placed back into Earth's gravity, the spaceborn jellyfish wobbled and struggled to orient themselves. Unlike their Earth-born counterparts, their statoliths hadn't developed properly, leaving them unable to sense gravity. This space hangover demonstrated that living organisms born in microgravity might face challenges adapting to normal gravity, shedding light on potential issues for humans born or raised in space. This experiment wasn't just about jellyfish. It was a glimpse into how life might evolve in extraterrestrial environments. The results highlighted how prolonged exposure to space can alter fundamental biological processes. For future generations of space explorers, and even the possibility of human colonies in space, understanding these effects is critical. The jellyfish in space experiment was a small yet significant step in the exploration of life beyond Earth. These tiny, wobbly creatures taught us that life in space isn't just about survival. It's about adaptation, resilience, and the surprising challenges of thriving in new worlds. In the summer of 1957, deep in the Nevada desert, the United States conducted one of the most ambitious and controversial nuclear testing programs in history. Codenamed Operation Plumb Bob, it was a series of 29 nuclear detonations designed to push the boundaries of nuclear science, weapons technology, and human endurance. But what unfolded during those tests would echo through history, raising questions about science, ethics, and humanity's place in the atomic age. The Cold War was in full swing, and nuclear weapons had become the ultimate symbol of power. To refine these weapons, the U.S. needed to test them under various conditions. Operation Plumb Bob aimed to study everything: the effects of nuclear explosions on structures, the environment, and even human beings. Military personnel, nicknamed atomic soldiers, were stationed near Ground Zero during several tests to study the effects of radiation exposure. These soldiers were ordered to march toward the blast site after detonation, exposing them to dangerous levels of radiation. One of Plumb Bob's strangest moments occurred during the Pascal B test. Scientists placed a heavy steel cap over a shaft containing a nuclear device. When the bomb detonated, the explosion generated immense pressure, launching the steel cap into the sky at incredible speeds. Some scientists speculated it might have escaped Earth's atmosphere, making it the fastest man-made object ever, though this remains unproven. Livestock were placed near the blast to study the effects of nuclear radiation on living organisms. Pigs were often used, dressed in protective gear to simulate soldiers, but the results were grim. Many animals suffered severe burns and radiation sickness. In 2015, aboard the International Space Station, an unassuming group of Earth-dwelling flatworms was sent on a mission that would challenge everything scientists thought they knew about regeneration and life in space. These simple creatures, known for their incredible ability to regenerate lost body parts, were about to show just how bizarre biology could get in microgravity. Flatworms, or planarians, are famous for their regenerative powers. Cut one into pieces, and each fragment can grow into a fully functioning worm. NASA scientists wanted to see how microgravity would affect this remarkable ability. Could flatworms regenerate as they do on Earth? Would the lack of gravity alter their biology? A group of flatworms was split into two batches. One was sent to the ISS, while the other stayed on Earth as a control group. The worms in space were cut into fragments to observe how they would heal and regenerate in orbit. As the experiment progressed, the flatworms in space began regenerating. For the most part, the process seemed normal, except for one peculiar worm. Instead of regenerating into a single-headed flatworm, it grew two heads, one at each end of its body. This phenomenon had never been observed in flatworms under normal Earth conditions. Scientists were stunned. What caused this mutation? Was it microgravity, radiation, or a combination of both? When the two-headed worm returned to Earth, it continued to live and function, retaining both heads. This suggested that the changes induced by space weren't temporary. They had permanently altered the worm's biology. Beyond the two-headed anomaly, other flatworms showed unusual behaviors. Some exhibited differences in movement and orientation, struggling to adapt when brought back to Earth. These observations hinted at how life forms might evolve under prolonged exposure to space.